Let's go a little bit deeper into JSX. Let's find out how JSX works under the hood. Let's go into our render method and console.log a div element. This code will be complete nonsense in a traditional app, but since we're working with JSX, this should work. We get this large object in the console. If we expand this on the first line, you see react.element with a type of div. This is important because this is essentially what JSX is. JSX is simply the function react.createElement being called over and over again behind the scenes. And let's set up an example to see how this works. Let's go back to our editor and delete everything except our React component code in an empty div. Inside that div, let's use the curly brackets to write some JSX code. Write the following code in the curly brackets: react.createElement and then parentheses, and then first a string of div, comma, curly brackets, class name, and then a string of app, and then finally just a string of react your name, and then close off the parentheses and the curly brackets. Let's save our file and see what happens. And yes, our code is in fact still working. And just to really be sure, let's change the string of div to the string of button. And if we save this, we should now be seeing a button. And yes, this is exactly what we see. This concept is important to understanding how React works under the hood. React uses what's called a virtual DOM, which is essentially a representation of the DOM underneath, but is not the actual browser DOM. The div in the React create element function is actually referring to a React element which is representing the div, but this is not the actual HTML div. How this div JSX code is converted to the normal create element function JavaScript code is through the Babel plugin for Webpack. And this is all default functionality we get right out of the box with Create React App. We don't have to set anything up. We don't need to do a deep dive into Babel in Webpack right now, but Babel essentially turns our ES6 and ES5 JavaScript code into basic JavaScript that is readable by all browsers. ES6 and ES5 JavaScript are just newer versions of JavaScript that make development easier, meaning it's easier to read and write code for the developer, but browsers can't directly read the newer versions of JavaScript code, so essentially we use Babel to convert ES5 and ES6 code back to basic JavaScript. And again, it's not necessary to understand how this process works at a deep level, but a basic overview is fine. And we can actually see how this works exactly by going to the Babel website and using their try it out tool. So let's go to the website and try it out. So go to babeljs.io. Let's click on the try it out tool and check the React box. And let's type in our JSX from our React app. If you copy div class name app and then the word React, the output you'll see is the same react.createElement function that we just went over in the last section. So cool stuff. So basically what this allows React to do is compare the virtual DOM to the actual HTML DOM and only update the HTML DOM elements that have changed. And this is why React is referred to as a single page application. It's literally only a single HTML file. When you first visit the site, the server sends you literally all the code for the website, and you stay on a single HTML page no matter what you're seeing rendered to the screen. If we go to our React app and under the Elements tab on DevTools, you can see there's a div with the ID root. For every React application, literally all the code is contained within these two divs. Even apps with thousands of lines of code and hundreds of components, all the code is within these two divs. And all the code is sent to your browser in one HTML file. There are techniques such as lazy loading to help with the initial load time for larger apps. So just to explain this a little bit more, essentially the server responds with one HTML file. The contents of head and HTML elements never change, so the DOM elements always stay the same. Only the code within the div ID root changes, and that's really what's displayed to the user. And we can actually see this in real time. Let's go back to our app.js file. Let's delete everything except the app.js and index.js files. Let's declare a new property called state and give it a property of counter. And let's set counter to 0. Next, let's declare an arrow function called increment in the code block and use setState to change the counter to 5. We'll discuss state and arrow functions in later sections, but we can skip them for now just for the purposes of this demonstration. In the render method, let's make 3 new divs and add a div with the number between each of them. And let's create a button that calls the increment method we just defined using the following syntax. And finally, let's add this.state.counter to the first div. Again, we'll go over this code in more detail in a later section, but let's just use this code to demonstrate how the virtual DOM works. We can now save everything and go back to our dev server. Open the DevTools and go on the Elements tab. Expand the divs so all the text and divs are showing. And let's click on the button. You'll see that only the first div changes and everything else remains the same. This may seem like a simple example, but this is literally how React fundamentally works. Even in extremely complex apps with API requests or other asynchronous actions, under the hood, this is basically all that's happening. Even with apps with routing, this is how it's done. When a new route is requested, only the parts of the DOM that have been changed are updated, and everything else is left as is. And obviously this results in huge speed improvements compared to traditional web apps. And just to expand on that point a little bit further, in traditional web apps, every route change requires a new HTML page that has to be requested from the server. And of course, this results in obvious lag and wait times while navigating the website. It is possible and actually standard in single page apps to navigate the entire website, including sending messages, writing blog posts and comments, and uploading files without ever having to reload the page. And again, the speeds are comparable to offline desktop apps. And this is why traditional web apps compared to single page apps seem archaic and slow. And the difference is extremely noticeable in mobile web surfing. So even though we're talking about only a difference of a few seconds, modern consumers simply will not put up with the slower traditional web apps when there are single page apps available. And this is why I think single page apps will be the future of web development and traditional web apps will be slowly faded out.